To start off, my name is Grant Ingersoll, longtime Lucene Solr guy. I think you already know me. I want to start off with, on the far end then, it really needs no introduction, Mr. Yannick Seely is one of our judges. Woo! The newcomer to the Chump panel, recent Lucene and Solr committer, Jan Hoydal. And Mr. Solar Cloud himself, Mark Miller. Now this is what Haas wants me to tell you about him, but I was trying hard to think of some other way to think about him, and you'll notice that he does not have a beer. So if anybody wants to buy Haas shots, that's a better alternative than offering to buy him beer. Haas is a longtime Lucene and Solr committer. He's an ASF member. You can ask him what a TIG welder is. He's a terrible speller. Anybody had spelling mistakes with Haas before? Yes. And he has been known on occasion to use the F-bomb. The F-bomb translates roughly in Spanish to... No. I do know, but I will reserve that. That's the key to learning a language, is to learn the F-bomb first, right? Chump credentials. This is the beauty of Haas right here. This is when he got married. And you'll notice Haas disappeared from a while from the mailing list, but he has promptly reappeared. He's big on, this is all about data visualization, by the way, a nice infographic here for people who are paying attention this morning. Here's another visualization. And I think the really cool thing about this graphic is Haas pretty much answers all questions on the mailing list. Except for it's actually at a log scale, I'm told, so it's really not quite as dramatic. The reason he did it was to show, again, that really nice dip there where he went off and did something like get married and move.
This is, for the record, my wife really loves this graph. That's why this is up there. She loves the fact that it's like, I only loved her for a month, is how she puts it.
All right, so here's how Stump the Chump works. Basically, we have a bunch of people who have sent in emails to stump@luceneeneurocon.com, and I've stack ranked those by joining that with the conference mailing list to actually who is here. So we'll give priority order to that. Otherwise, if you have another question, we will have a microphone floating around and we'll just take some random questions from the audience.
Later.
Ask the question.
Later, towards the end.
Yeah,
Start with you.
if we have time.
Yeah.
Or maybe just for some randomness in the process. So if your name gets called up here, please stand up and David will run towards you and give you a microphone and you can actually ask the question. And Haas may have some questions back for you, so he gets to stump you, maybe back. And then our most beautiful and lovely judges here will judge and lather, rinse, repeat. And then when done, we'll have the judges pick 3 winners.
But Grant, are there prizes?
And the 3 winners, I've got cash. So if you're wondering now, how do you ask, it may be too late. You're probably thinking, I wish I had sent in my questions. So 100 euros first prize, 50 euros second prize, 25 euros third prize, and we will divvy those up according to the judges. Either that or I may just run out real quick and go to dinner.
Don't mind me.
Hey, trying to cheat already?
Yeah.
So with that, I'm going to start with the questions. And the very first one is from a Twitter account from a fellow named Uwe Says. And the question is, I've heard loops cause problems with Java 7 and Lucene and Solr. How do I write code without loops?
Would Uwe Says please stand up?
Where's Uwe Says?
Yeah, I don't actually think you submitted this one though. So I'm pretty sure the panel members are ineligible to win. How do you write code without loops?
This, by the way, was just a joke question.
Yeah, that's a really hard one. I'm sure it's possible with like an infinite tape, maybe. I think this is a theoretical exercise in the 60s, but yeah, I think lots of macros and macros. That's my answer. Macros. Right. Final answer.
We actually aren't counting this one, but.
Oh, okay, good.
Yeah, follow him on Twitter, though.
Yeah, if you're not following Uwe Says on Twitter, you're not using Twitter properly. All right, first question, in all seriousness, and by the way, I apologize for butchering your name up front. Gregor Thulin, are you here? Gregor? Yes, no? No, do we have to be present to win the prize?
I think you have to be present to win.
No.
Yeah, but
That's not
cash.
fair.
I mean,
Let's
we're
get
not
the
sending
cash, dude.
cash
That's
in the
not
mail.
fair.
We're not sending cash in the mail.
I think if you win and you're not here, it goes to the rest. Somebody's buying drinks at the bar tonight.
Here we go.
I think Lucene
All
is
right.
already buying drinks at the bar tonight. Anyways, question is, I want to stop the search if the result will exceed more than 1,000 hits. Is that possible?
Yeah, so the short answer is it depends. The medium answer is yes. I know yes sounds shorter than it depends, but the yes has caveats. The yes is there's like a time limiting collector in Lucene. So if we're talking about at the Lucene layer, you can use things like time limiting collector, or you can write a collector which does this, which as soon as you get your 1,000th hit, your collector just aborts out with a runtime exception. It's pretty easy. You can find it on the mailing list, pretty easy examples. The long answer is don't. Do not do this. Do not even try to do this. This is a bad idea like 99% of the time, because the first 1,000 results you get could very easily be the shittiest results that you could possibly get, and the next 1,000 results after that could be gold. So most of the time when people ask this question, they're not thinking about the fact that they're like, oh, once I've got 1,000 results, I'm good. No, because the first 1,000 results could be the crap that would normally be on page 720 of your result set. You usually don't want to do that. There are special case circumstances where it makes sense, and in those special case circumstances, you need a custom collector. If you're doing it in Solr, you really have to write that as a custom plugin yourself, because frankly, I don't want to maintain it, because like I said, 99% of the time, it's a bad idea. Anybody? You've got a flaw
Panel?
with my reasoning? No? Comment? Woo!
Taking notes? All right. Is there Jeremy Garnier?
Jeremy?
Oh man, here's so much for my stack ranking process and the joins between the conference list and the email list. Blah, 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 blah. How do I do image search in Lucene and Solr? And I don't mean keywords tagged in images. I mean actually retrieving based on like shapes and things like that.
So really this becomes a problem of analysis, right? You have to decide how you're going to extract metadata of some kind from the image, because binary data is useless.
Not me.
Really what you want to do is you have to think about what is it you're trying to get out of the image. So for example, I've seen people who approach this problem and all they really care about is color. If color is all you care about, then you can do things like look at the color map for the image. You can look at, I forget what like JPEGs have an actual color map, I think, in it, and other things. You can do pixel analysis and sampling and figure out. And it's really easy to then say, okay, now I can make some terms, and I can say the term red should have the term frequency of 300 because 300 pixels are red. And it's a question of what you want to find. If you want to find things like how many photos have kittens, that's not really a search problem, that's an image analysis problem. And once you've analyzed the image through whatever great open source tool I'm sure is out there that lets you analyze images.
Like that one?
Then you're just creating term vectors of keywords like cat or the color red with a term frequency of 45 because there's 45 pixels. How you would do it in Solr, I would do it probably not in Solr. I would probably do it as a pre-processing stage because I'm guessing those kinds of tools work better when you do them in batch. If you were in, was it your talk? Yeah, it was. If you were in Jan's talk earlier today where we talked about the whole update processor model versus batch analysis and like doing whole corpus analysis, that really makes sense outside of Solr where you can really crunch all the data at once. But if it is a one doc per thing, if it's like you can do very quickly, given an image, pull out the metadata you want, then I would do it as an update processor.
Judges.
I'm looking at you, Jan. You're the update processor guy, Jan. You got to say something here.
I would just call out to Google image search. I don't tell anyone.
Pretty sure I could use that answer for every question here.
Mr. Miller? Mr. Miller?
Yeah, I don't know. That sounds good to me. Google image search.
Bring Mark another beer.
Moderator's going to say,
What? What did I miss?
Andre, you want to explain how you do image search?
Wait. Get the mic. It'll take David 2 seconds to get to you.
You can do it pretty easily with wavelets. So wavelets like
Okay.
car wavelets. You pass the image contents through a wavelet, and then you get coefficients, and then you simply do encode them as terms, and then.
But like, what are the coefficients of? Like, I don't understand.
Like you have a coefficient for this or that color frequency across the image, and then you encode them as terms with frequencies.
Isn't that what I said at the beginning? You do like a pixel analysis and sampling, determine how often red is prevalent, and then give it a term frequency
Yeah,
based
but
on that.
I think your answer was all just color-based.
Well, you're talking about other things besides colors.
Because wavelets also preserve some of the structure of the image.
Oh,
so
I
you
see.
can get cheaply, without any in-depth image analysis, you can get more or less the idea.
You can get the notion that red is very prevalent in the lower left corner and stuff like that. Yeah,
exactly.
Sure. Yeah. Can wavelets detect kittens? I didn't hear anything about kittens from you, Andres. At least I remember
new slide,
the kittens.
Uwe says, can you detect kittens?
I at least thought about the kittens.
So that project
someone think
actually
about the
uses Lucene, by the way, so I haven't evaluated, but go check it out. All right. So this is a bit of a long one. I will read it. I need to do some post-processing of documents and reject them by running some rules. So I have some business rules. Can it be done with Lucene and Solr? If so, how? The rules would be based on data in the index and also on other parameters, not in the index, but within the context of, presumably the application. I cannot write all the rules in the pre-processing and create a search criteria. Also, let's say that I can reject a document, then I can use a document type field to reject all the documents matching that type. I'm not sure if that's a question, but currently we are having to run the rules after Lucene or Solr return results. Would it be faster if I can reject a document within the Solr Lucene evaluation of the document criteria? Right. So I think in general this comes down to the real question here is, should I post-process my sorting results, or should I try to do that in Lucene and Solr?
Yeah, so an example of this, just because I've heard this problem described in another way before. So an example of this, if you're not getting it, is like, what if at the time the user does the search, you want to filter results based on profanity keywords, but you don't want to trust the index data. You want to do like a real-time check of the source content, because maybe it's changed since you indexed it. So you want to like real-time check, does it say fuck in this document? If it does, I don't want to return it. So the answer of how to do that, I would, you might not. So the answer of how to do that, historically this has been a really annoying, hard problem, and it's been like, you have to like over request. So if you want 10 results per page, you have to request like 200 of them, and then you have to keep track of how many you throw out, and then you have to like, when you get to page 2, you have to remember that you threw out 7. But Yannick, I believe, did some pretty good work on this thing called, what is it? Weighting? Do you weight the filters? Is that what's the magic term? No, all right, fine. There's a special option you can specify as a local param on a filter query, which says how important it is or how deferred it should be. So if it doesn't have this parameter, it's done the same way it's always done historically, where it actually gets cached. And it's cached as the doc set, and it's done independently of your query. So it's literally done across the entire doc set because it's assumed you're going to reuse it, which for something like go fetch this URL and tell me if it's got fuck in it is a bad idea, because then you'd be doing this, you'd hit every URL the first time and then you'd cache that, and you don't want to cache it. That's the whole point. You want this to be a late binding thing. So if you add this parameter, A, it doesn't cache it, B, it decides, like if you have 7 of these filter queries, it does them in order. So you give it a numerical weighting. You say like this one is the most important, this one is second, and it will only evaluate a filter for a document it's actually considering, and for one that's already passed the other filters that came in front of it with a higher or lower number. I don't remember the right order, but it's in the wiki. So you could easily do that as one of these filter queries that's not cached, that's deferred, and then it will only do the number it needs to do to make sure that that doc set works. What is the parameter called?
There's cache. Cache equals true or false, and cost.
Cost.
The cost,
That's
you
the cost.
say how costly this filter is to
Right.
run.
So the more expensive it is, the lower it will be used as it can, yeah.
And so you got that one mostly. It's the right pointer, but it can go further. So when if you say cache equals false, it'll not cache the filter because if you cache the filter, it sort of runs it over the whole index. And that can be expensive with these expensive filters. If you say cache equals false, it runs the filter in parallel with the query. And so sometimes you might still get a skip on the filter saying, okay, what's the next document that matches you? And that can be expensive again. There's another option where you can implement a custom query that implements the post filter.
Right, that's the part I forgot.
The post filter interface. And then if you say cost is greater than 100, it uses like a collector interface, and so it runs it truly after the query and all the other filters. Then it'll run it through this post filter to check whether it really matches.
Right. So that's the part I glossed over that in my head is that this logic, whatever the logic is, in my example, it was go out and fetch a URL and check if it contains fuck. You have to implement that as a custom query with your little custom Q parser. So your FQ parameter would be like FQ equals bang, the name of your custom query parser, profanity filter, space, cost equals whatever it is, space, cache equals false, and then the actual input to that parser. So you'd have to write that as a plugin into Solr to actually know what is this weird type of filtering you want. But then that cost option and that no cache option would be what lets it execute after the fact.
Jan?
I think you maybe forgot the external context, which you cannot express through a filter.
Well, like in my example, the external context is the web page, right? It's something outside. The point is you can implement whatever logic you want in that query parser to talk to whatever remote system you want. The key is you want it to be considered a post filter with that cost value so that it's done only on the documents it really has to be done on very late, as opposed to being cached and doing the whole corpus. What else am I forgetting?
Well, the beauty of this question is you could have simply answered with a yes/no question. Would it be faster if I can reject?
What? Okay, excuse me for answering the whole first paragraph. You want to skip ahead to the end, fine, you do that.
By the way, I love that when Haas just simply says FQ, it also sounds like he's swearing.
Yeah, FQ.
I think I would add that maybe I would do this as a three-stage thing. What you could express as pre-processing, I would put in the index.
Yeah, right.
What you can express as these fast filters with all this post stuff, I would do as those, but those which you cannot express in the query, I would do as the post filtering. And then you would have reduced your possible matches to minimum so that it's not that expensive.
Yeah.
It sounds
that's true. Yeah, the more you can do early, the better, right? So yeah, that's what building a denormalized index is all about.
I think we've beaten that one to a... Renee. All right. So, by the way, can I just note that Renee has proper deference to Haas here in that he is the champ, not the chump.
No.
So, a bonus to you in terms of the scoring algorithm for ranking the questions.
However, Haas doesn't give out the prizes, so nice try.
So why don't we'll let you ask the question in layman's terms.
Oh, you're here. Awesome.
Perhaps.
Okay.
Thanks. Well, first of all, I thought it was due to give some reference because Horst told me off lots of times on the mailing list, probably without knowing me. So I thought. And secondly, I looked up chump because I didn't know the word in the dictionary. And then I figured out, wow, this doesn't just rhyme. This is actually an English word, and it's not nice. I'm not using this word, and not my own profanity filter, maybe. So to those of you who haven't read the question from the back, maybe, so it's really a mouthful. I apologize, but I tried to put in only the most vital details, and here you go. So you have 2 indexes. Index A has 50 million documents and is about 2 terabyte size. Index B has 20 million documents with 500 gigabytes of size. And what you do is you make a query, like a term query, in index A. You extract all values from all matching documents from a field from this index. Then you take those values and you want to get, and I'm not saying you want to query, because maybe you don't want to query, but you want to get all the documents from index B that satisfy those values, but from a different field. And then in the end you want to display stuff. And I put some figures there to make this
interesting.
Well, the sentence I'm getting hung up on is this display stuff from documents from both indexes. Is it that you really want, do these corpuses have similar sets of fields so that you can really think of them linear as the same types of documents? Are you talking about more like an entity relationship that you want to join on? Or are these both like, is this like one corpus is books and one is magazines and they all have the same fields, so you want to think of them as one giant list, but you only want things where they're in common? Like, that's the part I'm not understanding.
Well,
what do you want the output to look like?
To give you one example, let's say index A is chemical structures, where you do a chemical structure search.
Okay. Now I have to remember chemistry. Sure, that'll be fun.
Yeah. And index B is patterns in which chemical structures are used.
Okay.
But you cannot do a structure search in those patterns because it's full text.
Sure. Okay. So like the index A, when you talk about it being chemicals, each document represents like a molecular structure? Or what is each document? Okay. So
yeah, you could say that.
Okay.
Or
and so then like the fields are like what kind of chemicals does it contain and how, okay.
Yeah.
Whoa.
Why the need for 2 indexes?
Yeah, I mean,
is there a business requirement for 2 indexes?
Are you trying to support the champ? I'm sorry.
No. This is the clarifying, because you've already said like query is a vague concept in your question, because you're like, it's not really a query, and I skipped ahead to like paging is not allowed. You really want this as one mass output. I mean, this goes back to my like XY problem kind of philosophy of it sounds like X in this situation is Lucene, and Y is maybe it should just be some completely, if you're not doing searches, if you're not dealing with relevancy, which it doesn't sound like you are since you're dealing with the whole doc set, and you're not dealing, then you also say, right, it should be working with different sets of data. This almost seems like it should be done more as a large-scale batch processing. Right?
What's the use case?
Job.
Can you say a little bit more about the domain that it's chemicals?
Yeah, chemicals, pharmaceuticals, for instance. Say I'm an aspirin producer, and I have an idea to make it last 72 hours, the aspirin.
Right.
So I want to know, can I really can I really do research on this subject, or has this all been patented?
Yeah.
So I make a structure search to find all the aspirin formulas that there are, and then I go into the other database with the info that I extracted from the structure database, and there are keys there.
Sure, yeah. But this doesn't sound like this sounds like the kind of problem that like large-scale Hadoop jobs are great at, because
we need to do this on the fly immediately.
On the fly? See, that's where
we need to do this immediately.
Yeah, the problem I have is that when you get it, problems like this tend to be really, if you want to solve them fast and efficient, you have to make trade-offs in how you're building your index and how you're designing things. But you've got this nice clause in here about how you need it to be very generalizable and work for arbitrary corpuses. And that's where you start getting like, okay, well, if you want the problem to be totally generic, then the solution has to be totally generic, which means that you can't necessarily take advantage of some of the optimizations you would normally want to take advantage of, which is the whole concept of building denormalized indexes and things like that. I think the best thing you can do is try to write some really low-level code that's extracting out term vectors, and then using those, since you want to analyze every doc, right? Instead of, a lot of times, like the join functionality that Solr has right now extracts terms and then uses those as a query. But in your case, you know you're going to be scanning everything, and you know you're going to be using a large number of those things. So it's almost like it's almost like you want to write it as if it were a MapReduce job, but don't do it in Hadoop and MapReduce. Instead, do it as a linear index scan and compare the term vectors as you go, almost. But again, you have that generalized weird caveat there where who knows if the two fields are even, what you say in your chemicals field, you may have like a molecule, or in your molecules field or whatever, you may have chemicals used, but that doesn't mean it's being represented in the same way. So you may have to actually do the kind of typical query formulation where you take advantage of analyzers to know about how the data is. If the indexes were built with this in mind, you could know that the terms match up, so you could skip some steps. But if you don't know that, if these indexes weren't intended to be used, you run. if these indexes weren't designed with the intent of being used together like this, you can't skip that step. You have to consider that, you have to query parse and know that over here it's lowercase and over here it's uppercase. That
You're not going to argue for Boolean queries, for instance, or query filters.
I mean, you could use it, but I don't know that it's going to be fast enough for you. You know what I mean?
You're going to argue maybe.
He didn't say anything about performance requirements. I will.
No, he said real time. He said it's got to go. You got to run that query.
In the question.
He just said it. If you're here and you have a mic, I take you over the slide.
No, what I mean is that
there's real time and there's real time, right?
Well, then I go back to my use something like pig, and let the user formulate their data structure. Skip Lucene, have your corpuses in Hadoop, have them formatted nicely so that you can run pig jobs against them, and then let people structure it that way and say, okay, I'm a scientist and I want to know. Go look at our patents corpus of all the known patents, and go look at our chemical corpus and tell me if anybody's ever looked into this, because it just doesn't seem like a good Lucene problem.
What would you think about field cache?
I wouldn't want field cache to ever come into this situation.
No?
Well, again, that's...
You have multiple values, though.
Yeah, I mean, one, you'd have multiple values, so you'd be dealing with uninverted index, but more importantly, you'd be dealing with terms at that point. You'd be dealing with the fully, this is post-analysis terms. This is raw terms on disk. And like I said, you're talking about a generalized solution between two arbitrary corpus. You have no idea if they were analyzed the same way to start.
Of course I have an idea.
Right, that's what I'm saying. So you couldn't even remotely try to do, you're back again? Make up your mind. Come or go. No, but you can't just arbitrarily compare field caches like that. You couldn't just do value comparisons across.
Yeah, you don't need to do those comparisons as you say, but for instance, you could place key values that map entries from one field to doc IDs in the other field, and then take the doc IDs.
Right, but that assumes that you knew in advance that you were going to do those comparisons across indexes. But you said,
of course I know I do.
No, but you said you wanted it to be generalized. That was my whole point, right? If you know in advance,
the customer's always right.
I took you at your word, sir.
I cannot read generalized anywhere there in my question. I'm sorry.
It should also work between many other not shown indexes with different properties.
Yeah, but.
Then I mean, if you have a fixed set of corpuses that you know in advance you want to be able to do these comparisons against, then absolutely, when you're building them up, you can be making references back to the other corpuses and save yourself that time. And then things like Solr join will work really well for you.
Final answer?
That's my final answer.
Thank you.
That when you're building the indexes, that you design them around the idea that you know you want to join against them, and that you have that sort of foreign key data, I guess it really is, kind of baked into the index.
Panel?
You did mention join, and that seems to...
I mentioned it very early, and then I discounted it based on some of the other comments, but now I'm back to it.
So, okay. So you got back to it. Yeah, I was wondering why you were discounting it, because that's exactly what join would do.
Right.
You'd do a join from field F.
Except for separate indexes. Can you do a
cross-core join even, yeah.
Right,
you can. It has bugs.
Join.
It has bugs with query parsing, but you can do it.
Bugs,
you still just have to define, as long as you define the field in the other one.
Why would you ever do that unless you knew about the bug?
From field F to field G, and then that would give you all the documents in B, and you essentially have to do two queries concurrently, one to get the documents out of B and one to get the documents out of A.
Right. But I mean, more specifically though, the fact that he's talking about not dealing with paging and dealing with whole result sets at a time is why I was not treating this as a Solr question and treating it more as a low-level implementation question.
Yeah,
but the same
not allowed.
fundamental.
That's orthogonal though.
Yeah,
paging.
that's what I say. The same fundamental logic of how that join works with the foreign key type model. So.
Jan or Mark? Cross. All right. Good question. I liked it. This is not Uwe says. Where's the one of the other Uves? I think there's a few Uves here, maybe.
My question is maybe more academic, or maybe just throughout me as a newbie. In core scaling Solr can told us some stories how to use head-up to do a distributed index generation with embedded Solr as a reducer. And this results in quite a lot amount of indexes which have to be brought together as shards.
Right.
My question is there an efficient way, like the merging when I do an optimize, to bring them together to a single core and just to have the benefit like in a sorting problem, you have pre-sorted lists and merge them together is faster than sort all the stuff?
Yeah, so I mean, at a fundamental level, especially you mentioned specifically you're building your indexes with embedded Solr. At a fundamental level, any two indexes that have the schema in common can always be merged together because any two indexes can be logically viewed as segments at a higher level. And just like segment merging works, index merging works, there's a low-level Lucene class where it doesn't even have to know about the fact that it's ultimately a Solr index or that it has a schema or anything, that will just merge indexes, which just calls out to the same segment merging code. In Solr, there's actually the core admin handler even has a command, index merge, which is where you have indexes on disk that are not currently being served. They can't be live cores. But the point being, for example, if you've built these in a distributed fashion and you say this box over here is where ultimately I want the merged core to live, you have to get those indexes onto that box, and then just by passing directory names to the index merge command, it will take those and merge them up into one directory, which you can then start as a core using that same core admin request. So you can do it all. Once you've got the data on the disk, even if it's in many directories, you can execute it all through HTTP with Solr. But at just a higher level, anytime you have indexes which are logically similar, which means different things for different people, but for Solr users it means same schema, you can merge those either using a Java tool. There's a command line version of it that comes with Lucene. You can just run java-jar.
Can you say something about timing aspects? Would it be faster than building the index in a single machine? Or would it be slower because the merging is more expensive?
Yeah, that I think it depends more on. I think the specifics really become important there because usually when people talk about they want to do distributed index building for speed, what winds up being the speed factor there is how much can they distribute it, right? Over how many millions of machines can they distribute the load so that each machine is dealing with one document at a time? How complicated is their analysis chain, since that's what tends to take time and tends to be, CPU bound. And then how long is the merge itself? And the merge time itself is not, from what I remember, and this is not an area of my expertise, so this is a good question, but the merge time is largely dependent on how much overlap there is in the terms. So if you have two completely disjoint indexes, I think that merge goes relatively quickly. But if you have two indexes where the terms themselves overlap greatly, then I think you'll see the merge take I don't know how many orders of magnitude, but some amount of time slower. So knowing how many machines you've got to work with initially and how many total indexes you're going to have before you merge is a huge factor in that question to know whether it's more efficient or not. And then, like I say, how complicated is your analysis chain? How disjoint is the data going to be when you're all done? I wouldn't even begin to predict it, even if I had a chance to win the €100 if I was right. I wouldn't even guess.
5.
I have 5. I have 5 chances to win. That doesn't even make sense. That's not even a percentage. What?
Final answer?
You are an academic. You should know what a chant on odds means. That's my final answer.
And just so you know that at Lucene, we do indeed have a 1,000,000 node cluster.
Millions,
Judges?
plural, millions.
Judges? All right. Moving on. Mikhail. Are you here? All right, he is here. Great.
This max doesn't help me.
This max doesn't, that's all you're going to add to this? I'm only like a third of the way through the slide, and that's the only hint you're going to give me? This max doesn't help. Okay, right. There's no match on that. Wait, why doesn't this max help? Now I'm confused. Oh, sorry, I'm blocking the slide. Conjunctive like Mac on subphrases of the query. Wait, why shouldn't these should totally match? Why doesn't this match? This one right here. So,
sorry.
He's asking a question about basically like if you're familiar with like the dismax parser, the idea is users give you multiple words, and you, independently of them giving you multiple words, know what fields you care about and weight them. So, for example, you say the brand field is pretty important, and matches on brand are really, that's important. Matches on type are really important, but maybe matches on style are a little less important, if you find that keyword there. So if the user gives you bootcut Calvin Klein jeans, you want to search for all of those words and all of those fields, but depending on which field you get a match, you want to weight it higher. And the thing I don't understand is why this doesn't match.
Because
why wouldn't
you can't
Calvin jeans Klein
compose subphrases? You can't cut this phrase into subphrases, and
but wouldn't the individual terms match? Wouldn't Calvin and Klein each be matching in brand, and jeans would be matching in? I mean, I know you wouldn't get the phrase boost. Dismax has a feature called phrase boosting.
There is no term Calvin at all. There is no term.
Oh, because
Calvin.
you have a tokenized brand.
No, you should not tokenize brand.
Well, you should not tokenize brand for a facet on brand, but you should tokenize brand for a keyword search on brand, right?
If we tokenize multi-word brand, we will have match, for example, for Annie Klein and Calvin Klein.
Okay, gotcha. See, that's the part that's not on the slide. That's the key to the question, right? You don't want false matches. If somebody types in Calvin jeans Klein, or even for that matter, if they type in Calvin Klein jeans, you don't want a loose partial match on Anne Klein, right?
Yes.
Yeah. So out of the box, I don't know of a perfect solution to this problem. A helpful solution to this problem is to not use mention match, to use it but to set it to 100%, to force there to be a match on Calvin and jeans and Klein in some field to reduce the likelihood that Anne Klein jeans match, because what are the odds that Anne Klein jeans have Calvin in one of those three fields, right? So that can help. It helps in that example, but it doesn't help in the general. I know.
It doesn't help.
The ideal solution is to do more subphrase splitting of your input, and I've done this as a mental exercise in the past, and in theory it works. The code just doesn't exist. But what you really want, I know it sounds bizarre. What you really want is you want to build a hierarchical query structure of every permutation of subphrase, see what kinds of matches you get, and then weight based on the longer the match is. You follow me there?
Yeah, actually, what I've done for this.
Okay, well, wait, hold on. Don't tell me what you've actually done, because that'll spoil it, right? But the point is, if you take that input, right, if you've got 4 words, or let's do the Calvin Klein jeans. You build a query structure out of it where anybody who's got a phrase query matching Calvin Klein jeans, or if it's, if the field's not tokenized, then it should be an exact match for Calvin Klein jeans. That's huge. That's one clause of many, where the other clauses are all shingle-based. So you've got another clause which is just Calvin Klein, just Calvin jeans. You've got another clause which is jeans Klein, another clause which is Calvin Klein. You build up a very complicated query structure with the appropriate weights on each of the individual clauses based on both how close they were together in the original input and how long the total input is. Because this is kind of a badly formed query, but imagine there's actually a brand called Calvin Jeans. You'd want Calvin Jeans who have a style called Klein to match better than Calvin Klein who has, a type of jean, right? Because these are closer together, so in theory, those might be a better match. So you'd want to weight those based on how you've split apart the user input and build that kind of complicated query. That's the ideal solution that I've thought of in the past when I've had to deal with this problem that no one has ever paid me enough to go build. Because every time I tried to explain it to someone, their eyes rolled in the back of their head and they're like, you know what, min and max is fine. I said paid me enough, not paid me. They were paying me. They weren't paying me enough.
$50 here?
Like I said.
150 euros.
But that's how I've thought about the problem in the past. Like, the specific example I've thought about was also where then, when you're doing that splitting, you don't just build that query structure, but you're also checking your term enumerators for your keyword, what I consider like your key facet fields, like type and style, so that you pull them out of the relevancy completely. So as soon as you see the word gene, you say, you know what, I don't want TF-IDF scoring of gene on every field. Gene, my editors have told me anytime I see gene typed into my search box, I should immediately convert that into a filter query on category 723. Because category 723 has metadata associated with it in my taxonomy that tells me that's associated with the concept of gene.
I think we had audience participation back there.
What?
Yep, go ahead. That's you, yes, you.
What?
We had
What's
audience
going on?
participation.
We have audience participation?
We have similar problems with two different indexes completely, and employ the one thing you just started to explain. We have the vocabulary with all the possible, not all the possible, but most occurrences. For example, we know that Calvin Klein is this trademark. We know that jeans mostly is this. Not style, but
a type, a category,
and so on. And we use this to build the queries. Sometimes this result in two queries in one. So one options how we can parse, and second option how we can parse this query. The other in other index we have we generate in different fields all the possible, from our perspective, permutations, how this how user can combine the words.
And then do phrase searches on that one after you've pre-computed all the permutations?
It's a music search, so probably we assume that when you're looking for some music, you first of all enter the artist name, then you enter either album name, either you enter the track name. So we use this to.
So in this little sidecar index, each document corresponds to a concept they might be looking for, right?
Yes.
So you search that one first, and if you get a match, that tells you you've got a good concept based on what they might have been looking for?
No, we use our custom query implementation, which collects all this and arranges in very complex manner.
Yeah.
So not for this case.
Sure. Yeah, yeah, okay.
But
the hand wavy part now.
Generally, these solutions also works and works fine.
Yeah.
Cool.
So we've just identified our chump for next year?
Yeah, no, that's good. Okay, so I'm pretty sure, so that's how I would approach it, and that's how I've thought about the problem, but you said you've already done a different solution, right? Give him the mic back. What are you doing? Stop hiding the mic. Somebody should have the mic at all times.
You can't score terms by dictionary because the term like jeans can belong to two different fields.
No, right. That's what I say. It's got to be kind of probabilistic. There's some things where you want to treat it that way, but I mean the classic example I hate is there used to be Yahoo's like local listings. If you typed in keywords that match categories, they would automatically put you in that category without any way of escaping it. And that's a terrible UI model because there's a store in San Francisco called The Magazine. And when you tried to find The Magazine in Yahoo Yellow Pages, you just got a list of every magazine stand in San Francisco. And you could never say, no, fuck you, search the name of the store for the word magazine. So I view that as a UI problem. I view that as when you write this custom component or custom query parser, the default behavior in absence of other information should be to probabilistically say what are the odds that when they use that word gene, they meant it in the category. And you should either have an editor or some out job which is deciding for you, based on the prevalence of it in my corpus, how likely is it, how many docs are in a category named gene versus how many docs have gene in the description, right? And based on that, that's your discovery and analysis concept, is deciding how likely then should I assume that's what they meant if it's included in the search. But you should always give them the option and factor that into your UI, that if you've guessed wrong, they have a way of saying, fuck you, I really wanted products that have gene in the name. No, this isn't an FQ, this is a No, yeah. No, I said it right, it's cool. So that's my strong opinion on that.
Is, which field you will use to generate all these complex queries?
Which field? Oh, well, see, I think you want to do it on all of them, right? I think
plus your logs, right?
What?
Plus your logs?
Well, to generate. No, you're saying which query? Like when I build this huge query, which field is it against? That's the key. That's why it's so huge. Is it should be against all of them, Dismax style. You should pull out each one of these pairs and all those permutations,
but
and
they
then
have 400 of queries.
Yeah, keep going.
400 of fields.
Yeah,
and
keep going.
Queries
it's good.
About
machine learning.
8 words.
Yeah.
8 words, so it's
I'm good.
Really huge.
Yeah, thousands of clauses is not a big deal.
Number of combinations.
Thousands of clauses is not a big deal in my opinion. Until your performance, thousands of clauses in a Boolean query is not a problem.
All right, now we're just going to cut them off.
Until your performance metrics tell you otherwise. Until you have performance data that says it's too slow, it's not too slow. Try it. And then when it's too slow, then you go put in search discovery to say, how do I rank and weight these to cut down the number of clauses I need to use?
Jan, go use Google image search.
It's a very good solution, I think. And the reason is because I actually built that code 7 years ago.
Where's the patch?
Where's the patch?
No, because 7 years ago, Solr wasn't even existing.
Yeah.
So this was with a fast product at Telecom Italia. And we wrote the plugin with C++, permutating all the different lengths and combinations of the input terms, which is generally a bad thing to do, as you say.
Yeah.
But then running each of those queries and looking at the hit counts, we selected the best probable option. And it worked really great. Yeah. So kudos.
Like I say, on paper it looks really good. I just never got around to writing it.
In code as well, at least C++.
Yeah.
By the way, our profanity filter, unlike TV, is instead of him being delayed by 7 seconds, I'm delayed by 7 seconds.
The filter is delayed by 7 seconds?
Panel, anybody else? Yannick, Miller?
Do you want me to summarize that for you?
Let me hold on. Wait, document older translation for right. Yeah, older docs get index first. Chronological shard index. Rankings relative base. Wait, your ranking is mostly recency. Oh, recency. I'm sorry, I read that wrong. I thought it was relevancy based. I'm like, wait, that doesn't make sense. Yeah. So this is my prediction for winning, because I'm going to try and figure out it. This is one of the first ones where I have no idea prior to reading this question, even remotely, how to approach this. So I'm going to keep talking about how I haven't thought about this yet until I think of an answer. The closest I have ever come to thinking about this problem like this is people who, in describing their use case, talk about how 90% of their users only search data in the last week. And then the other 10%, mainly search in the last month, but sometimes they search the whole thing. And then what we talk about is index sharding by time, essentially, and saying you've got your index, which you're constantly adding to, and then as soon as midnight rolls around, you go core swap, and now you have a new core that you're writing to, and that old core you name based on its date, and then when the week is ended, you merge 7 cores, but the dirty secret of all of that is that only is the indexing side. The query side, you have to solve in the application, and when the user says search last week, you do a shard query across the appropriate indexes, and when they say search one day, you point at the core that you know is named after today, and when they say search everybody, you have a really long shard parameter as you search each of these, like either week or month or year, however much you've been able to merge it based on how big those are. That doesn't really help the case though of like I want it to just work. I just want to programmatically take in a date range and know the right
I'm
cores.
already doing that. So
Right, you're already doing that, but there's no like built-in solution for you, you know?
Right. So within the last week, take the example of news index, for example. So it's possible that even after sharding, I might have a huge number of hits for a particular query within one shard.
Right.
So what I would like to do is just limit to the most recent 1,000 or 2,000 documents, get them out, and then re-rank after retrieval based on any other criteria.
Well, wait, but that one shard should be like today. Right? Oh, you're talking about the guy who hasn't given you a date range, right? You're talking about the case where he hasn't given you the date range, but your relevancy function is taking into account date. So you're pretty confident that since you've gotten so many results in today's shard, that you don't really need any of those other shards.
Within today's shard, even I don't want to want Solr to scan through all the documents to rank them. Rather, I would just have it look at the top 1,000 to speed it up. So if I'm doing like an instant implementation.
Okay.
So normally the hint here would be right that you could just go in reverse doc ID order.
Right. But you
have a
can't.
caveat that says things might be out of order.
So mostly I index them as soon as I crawl the documents, but I recrawl the documents sometimes.
And sometimes they change.
30% of the times.
Yeah.
So that messes up the ordering of the documents.
Right. Is this? I should have asked. Is this? Are you doing this in Solr or are you doing this in general? Like
this is in Solr.
It is in Solr. Okay.
Yeah.
So that's it's kind of a key caveat in terms of how deep you want to go in the guts of changing stuff. I think maybe the earlier comment about a post filter can maybe help you here, except for that 30% of the time where you're re-indexing stuff. Because what I would say is maybe like a custom merge policy where you are actively reordering shards, where you're trying to deliberately say, I know I want the newest stuff first, so when it comes time to merge those shards, merge everything but then kind of try and reorder them. I'm not entirely sure you can even do that, but I would say that's what I would look into, is can I write a merge policy that actually reorders my shards to get the newer stuff earlier, except for that 30% where the newer stuff is not necessarily later or earlier, right?
But this is still across shards, right?
No, I'm just, like I say, I'm just thinking about it in one shard first, because that's a hard enough problem as is, you know,
Right.
and that, I don't know, maybe having more shards is actually helping you in that case, right? If you actually, if you could shard by hour, right? Then you've punted this to an indexing problem that if you re-index all your data, it has to be smart enough to know what shard to go put it in.
Sure, that's possible.
So then you could have your sort of custom search code query shards in order until you're relatively confident you can stop. But I think that's hairy. I mean, I sure as hell wouldn't want to try it.
We considered it, but doesn't sound like a good option.
I mean, it's the only option I can think of, but that doesn't make it a good option. This is where I'm hoping one of these guys has something better. Yeah, Yannick's like grimacing.
I'd technically disqualify him when there's no question mark. That would be my answer if I was the chump.
Right, yeah. That is why Grant is a dick.
Bleep.
Anybody have anything useful to contribute to this discussion?
I think that is...
Anybody? Miller? No, Miller's grimacing too.
Muir.
Yeah. Anybody?
Mueller.
I want to. Anybody? Hold on.
Our next year's chump has
right.
an answer.
Right. Is this another problem you've already solved?
We have the similar problem, pretty similar, and we solved it as you describe it, and there is not a drastic something. Yes, it's but we work on Lucene, not on Solr.
Right. But I mean, it's the same problem either way. It's just a question of what the code looks like when you write it. Do you have to fit it into the Solr framework, or can you just make sweeping assumptions about everything because it's all yours, you know? But it's still the real hard problem is still deciding when to stop. It's deciding what shards to look at and how many, and then doing the merge when your results.
How often?
Right.
And how to resolve the problem of updating an existing document.
Yeah.
But it's.
But I'm saying like at query time, because all that other stuff is kind of back end. It's just picking good naming conventions. But at query time, especially when it's not a pure sort by date. If it's a pure sort by date, you can literally just stop when you have enough. But when sorting by date is part of your relevancy function, you have to actually do like kind of predictive estimates on knowing that the next shard is only a day, and therefore the max possible score it might do based on what my scoring function is this, therefore I can skip that shard or not, you know? Like that's where you really have to like, that just seems like it gets crazy complicated. Yeah, you follow-up comment here.
Is there any way I could ensure that my shard has the document sorted by date no matter when I index
And
them?
that's why I say that goes back to my comment. I think you could probably write a merge policy that would at least make sure the segments are in the right order. But the only way to know that they're ordered by date is to write a process that goes through and reorders them all. And that's
index sorter.
Right, either there's an index sorter tool in Nutch that does this, or when you're building it in the first place, you have to do it.
This is an incremental thing, so
yeah, that's the problem, right? So you would essentially have to, after adding as many documents as you know you're going to add for a reasonable amount of time, resort your index, which is essentially rewriting every segment again, which is not pretty. But that's why I say if you can do it in batch, do it in batch. You know. Yeah.
My use case doesn't.
Right. No, I understand. Right. It's, you know.
Okay.
We got another comment from the next year chump.
Can we just give him a lapel mic? No? Okay. All right. We're going to move on to the next question. We're going to move on to the next question. Sorry.
I wonder whether you could hack the low-level codecs to
well, that's what I was trying to figure
ID, out. Maybe.
That's why I was thinking it might be. That's why
I've had a few too many beers.
Yeah.
Alex, are you here? We got a lot of long questions this year. I'm glad I am not the chump this year. Alex, are you here? So my question about Solr and Lucene is what is the best, or more or less a good, way to solve the following problem?
Right.
In my application, I have the following domain model. I've got an analyst, entity, and research entity. Analysts write research reports, I'm inferring here. So each analyst can be an author of many research reports and vice versa.
So did we already determine Alex isn't here?
Yeah.
Okay, because if Alex was here, I would say, hey, Alex, did you see Mikhail's lightning talk? Because if you did, I'm saying your name right? It's Mikhail? What? Mikhail, yeah, Mikhail, right. So Mikhail's lightning talk touched on this, and if you don't see the connection, the idea here is you can deal with this with multi-values and spans. There's a bunch of other ways you can deal with this, where you can take advantage of things like field collapsing that got added. You could do it with join even. There's a lot of different ways to solve this, but this particular type of use case where these things are not kind of changing very independently, it's really a tightly bound entity relationship. You can have multi-valued fields on your documents where you do pairwise span queries using field masking span query to say, I want to match in these two fields, but they have to be at the same position. The only one that's tricky is date, because nobody's bothered to write a span range query. Patch is welcome, but conceptually, that's the easiest way to solve this problem once somebody writes the code.
Span range query?
Nobody's written this. So that you could do a date field, but also constrain where it is in a multi-value. To say, I want to match on this date range, or a numeric range of any kind, but that match has to exist at term position 4 of that multi-valued field. That doesn't exist.
Yeah.
There's no span range query.
You can say match at term position 4.
But not on a range query. That's what I said, not on a range query. If you were modeling your dates, if all you needed, like this is for the last year, so if you really only cared about years, you could just index each year as a term and you'd be fine. But if you need to do arbitrary numeric ranges, you'd have to do them as terms in order to get that position right. Yeah, we'll see, and block join can handle a lot of this stuff. The Solr join query parser can handle a lot of this stuff. Field collapsing can handle a lot of this stuff, all depending on how you model the data. But that's why I say I think of problems like this where there is that tight coupled relationship and majority of the data is on this side of the arrow. That's where I think of the multi-value with the field masking span really making a lot of sense. When the majority of the data is on this side of the arrow is where I think of block join query making a lot of sense. And where these two things are updated very independently is where I think of join, like the join queue parser making a lot of sense. The block join query I think really makes a lot of sense in the book page model where you have tons of text and you really want to get, because nobody's going to search for research, right? What they're searching for always is analyst. You could, no, right. I'm not disagreeing, but I just like, from a mental model standpoint, what you're always searching for as an analyst, so it doesn't make any sense for research to be its own document. No, I know, but with block join, the research of that analyst would be its own document, right? Child document, right. But at no point do you care about research independently in this use case, which is why I think as a mental model, it doesn't make sense as a subdocument. It is, right. That's why I say it is a property, but that it only exists because of this, that no one ever queries independently. But again, that's just my mental model of it. Like you say, you can absolutely solve it that way, and it's probably more robust for other things you might want to do later, but it also doesn't exist in Solr yet. So that's
all right. We'll take Mark and Haas's. You guys can go fight later. Panel.
Field collapsing, block join, and join. I mentioned them all. Yeah. And field masking span. Where's your mic? Use your mic. Nobody heard what you said.
No. Use joins.
Use joins.
By the way, we didn't get a ruling from the panel on this one. I think he was pretty well stumped.
Yeah, I agree.
Okay.
So I'm Alan Woodward from ProQuest. A lot of our customers are librarians, and librarians really like big lists of things. So if you do a search on something, they want to know, before they even do a search, they want to know the name of every single author that could conceivably give them a search result. So normally you do that on a facet. Okay, you've got your data set, you've got a facet of all the authors. Unfortunately, that facet has 1 million authors in it, and after a while, the librarian comes back and says, "You've given me a list of 1 million authors. That's no use." So they want to search within that facet.
Mm-hmm.
Is that possible?
So the use case is possible entirely with Solr. The solution, though, is not to search within facets. The solution, and the funny thing is, as you're talking, I saw Tom Hill out of the corner of my eye. Now I've lost him in the room, but I actually had this exact discussion. There, that's where I was looking. I had this exact discussion with Tom Hill almost, I think, exactly a year ago. The problem model, though, is that they want to search. If you want to search, what do? You build an index. So what you really need to do is conceptually think about that problem, even if ultimately you feed that data into an author facet, right? First, you start by saying they want to search authors. So let's build an author index, because they're not just going to want to search the author's name. They're going to want to search variations on the author's name. They're going to want to search stemmed versions of the author's. Well, actually, for author's name, that doesn't apply. For some other use cases, the point is there's various ways they're going to want to search on that. They're not just going to deal with the simple canonical version that most likely exists in that facet or most likely exists in the book model. So I approach that problem anytime. This really makes sense. Like anytime you're dealing with a facet that's so big it blows out your field cache, it's either not a good idea for a facet or it's a good idea for its own index, in my opinion. So you start by saying, okay, well, I can facet on this author field and I can give you the top results, but that's not really useful to you. What's useful to you is to give you an author search and join that against a book search if you also have requirements for the book. Or give you an author search, and once you've found the author you want, have a link which then redirects you to a page where I've now searched for books and I've applied a facet filter on an author field where maybe I'm not even using the author's name. Maybe I'm using a unique ID, but I got that unique ID from my author index, right? I've been doing this blog about the ISFDB database, and I do kind of a similar thing. I've got author documents and I've got book documents, and I could facet on the author field, but I know that that's going to just blow away, especially with really prolific authors. Have I been drinking yet? No. With prolific authors, those facets are just going to be largely useless. But what you can do is search for author docs first, and then for each one of those, it's like, okay, well, here's metadata about that author, and here's the link that takes you to a book search where I've constrained by the numeric ID associated with that author in the books database.
And so can you generate those author documents on the fly as you're feeding stuff into Solr? Or do you actually have to do that beforehand?
This goes back to my comment about when Jan's talking about when you're talking about doing stuff on the fly, you really want it to be single document centric. And for the model of books, you're not single document centric because you're talking about data that spans across the entire book corpus of what are all the authors. I would treat that more as a pre-batch distribution kind of thing to say, as whatever your canonical data store is, as you're adding books to it, you should be saying, what kind of metadata do I have about the author of this book? Does that match using whatever loose coupling match job I want to do a known author. Because maybe this publisher, maybe it's the first time Stephen King has started publishing with his new publishing house, and for whatever reason they've decided to put an umlaut over the I in his name. So you may not get an exact match on an existing known author, but maybe the other metadata lines up so that you know it's an existing record. And if it isn't, create a new record for it and then index that guy. That's how I would approach that problem. And that's how I have approached that problem in another domain that I'm not going to talk about.
Okay. In the UI I presented, there was this functionality existing, search in facets. So I can say technically, the answer is simply yes.
Yes. Yes, although it's not on a slide, so I can't point to it.
The thing is, we use a Lucene core, we don't use Solr.
Yeah.
And the other thing what I can add on this, just for clients, we provide the UI as source code, so you can see how it is done. So we can maybe add something to the community.
I think that would be a great idea.
Yeah.
Patch is welcome.
Okay. I think now it's consultation time, right?
I think now it's consultation time.
What, we have one more. Let's do one more.
Yeah, we got time for one more.
One question? All right. One last question.
The question was, I'm working in a company where we are doing reporting, and because I have users that are bothering me with a question, okay, I want to send you the filter with thousands of values, and because it's all about the user, I cannot say to them, okay, why you have to send thousands of values in a filter. I can say that I have one index. Index is not so big. Let's say 5 to 10 millions of documents. In that index, I have a field. In that field, I have the cardinality of approximately 2 million different values. And the users are sending the filters, the term filters, and having up to 50,000 different values. I can add that I have to deliver exact results. That means I cannot say, okay, I'm analyzing these 50,000 values and I'm finding that the following 20 or 30 are the most important, and I can throw away others and do reporting with 20 or 30 that are most important. Even though these 20 or 30 made something like 99% of the traffic, I have to exactly say you had so many clicks or so many views, and that has to match exactly. That means I have to take care about all 50,000 IDs, values that they are sending.
So wait, these 50,000 IDs that you're getting, these correspond to, there's just a field, I'm going to give you an exact use case, and you tell me without telling me your business. So is this like you run shopping portals for hundreds of merchants, and you have the union of all the products they sell, and for each product you know what merchants are selling it, and they're giving you like big lists of every product that they're interested in, or
Yeah.
Okay, that's close analogy. So the key is you know about millions of products. They know that they have these 50,000 products, so they send you a query and say, tell us for this store which sells these 50,000 products, which I'm going to give you IDs for, which ones match the query for blue, right? Is that a good use case?
Yeah, you are good.
Okay,
yeah.
So the short answer is, why don't they just send you 50,000 IDs?
Okay, they are sending me 50,000 IDs,
okay,
and then I have to quickly. That means
sure. Yeah. I mean, we're assuming speed of light on the wire, right?
Yeah,
like Ethernet
exactly.
is fast.
They want to be that.
So then you're just building an OR query out of that, right?
Yeah.
That should be simple. I mean, that's or 50,000 ORs. That's pretty straightforward. I mean, really, this just becomes a bandwidth question, right? It's just about sending the query over the wire. That query itself should be relatively fast, right? Because it can do skip lists on these things. I mean, it can't be cached unless they send you the same things over and over again.
Okay, they're sending me, but I'm asking when I send to Lucene the query that the terms filter that has 50,000 values.
Sure.
It took some time.
Yeah, but I mean, it takes how long it takes, right? I mean, that's the whole point. You can if you can rethink about the problem in a different way. If you can say, for this user who's going to send me lots of queries, the set of 50,000 things doesn't change very often. You can let the user send it to you once, and you could think about it from like a web service standpoint of going back to our merchant example. The products I sell isn't going to change for the rest of the day because FedEx has already come and gone, so I know what I've got is what I've got. So I'm going to use your web service to upload the list of 50,000 products that I use, and you're going to write that to whatever data store you write it to, and you're going to give them back a ticket. And then the next time, they're going to send you that ticket and say, constrain yourself to these products. And if the ticket duration is long enough, you could actually re-index the products and put those values in it. If it's really short, you still have to build that query, but at least now you can cache it for as long as that ticket is good. If they tell you, I only sell these 50,000 products and I want a ticket that's good for 24 hours, you can, in the background, like while you're sending them back the ticket ID, go execute that query to build a bit set out of it or a doc set out of it, and hang on to that for as long as they've told you it matters, and then use that as a filter later. So you're not have to actually execute the OR query with 50,000 clauses every time they do a search for the next 24 hours. You just cache that doc set or bit set. It took 2 minutes or whatever to generate. You do it once, and then you cache it and use it as a filter, so it's not reevaluating every time. That's how I would probably approach that, on the assumption that I can issue those tickets and they have some duration. If I can't issue those tickets and they don't have any duration, I would charge them lots and lots of money and give them their own dedicated box. And whenever they send me IDs, I would add and delete from the index as needed. I don't know another better solution to speed up OR queries.
I was started to thinking about solving that problem in that way, and then I started to analyze how many users I have that have something like 50,000 different IDs, and to see if I can predict for them and pre-compute. And then I discovered that I have thousands of users.
Yeah.
And because of that, in a question, I said I cannot do that prediction. But I was not attending on a last conference, Eurocon in Prague, and there somebody gave the hint that maybe you can put additional field in an index, and there you can try to do something like approximation of your IDs.
Yeah.
And then if you're doing that ordering of filters and saying, okay, that approximation of a filter is going to return me a little more.
Right, yeah.
And then the second filter is the filter with 50,000, but that filter with 50,000 is then attacking not 5 million of documents, but maybe only
Right. Yeah, I mean, if you can split the problem out and say they're sending you 50,000 IDs, and some of those IDs change every time, but 49,500 of them are always the same damn ones, then you can tell them, pass me those as two separate options, right? And you can build that set and pre-compute it and maybe even generate it in your index as a single field. Absolutely. If you can split that out and treat those as different problems, that'll make it a lot faster. Like you said, the really fast way to do it is to say, this is a set, everything in this set. When I index that document, I will give it a field that says part of set A. So you can just search right on it. But even if you can't do that, even if your index has to be static or updated independently of this kind of feature, you could still go like the doc set approach I was talking about, where you give them a ticket back and you generate that set for them, and you just intersect it as part of a filter. But yeah, that's the caveat you didn't mention, is that like I get 50,000 and they change. It's the rate of change, right? It's how many of them change. If 49,500 of them change only once every 20 years, cache that. And then go do the other 500. What?
I'm going to start a Twitter account that's Hoss says.
I don't know.
We'll do one more. All right, we're being
this is not a question, actually. In response to the question, we wrote a solution to precisely the same problem that we use to search for people's favorites on Etsy. So we have one index that has all the listings on it.
That's a much better example.
On Etsy.
Yeah.
But every user's favorites are different. And the gist of it is, and this solution was open source, so it was mentioned by Greg Donovan in San Francisco. The gist of it is that we basically build a cache of every ID to the corresponding segment and Lucene document number inside that segment, and then we have a Solr parser or a query parser that builds a filter and a bit set using that cache. That makes sense.
Cool.
But you're building that per user. When they change their preferences, you
No, literally when they issue the query, we figure out what their favorites are.
Right, but that's what I'm saying. When they issue the query, you have some data store already which tells you on the server side, right, what are their favorites.
Yep.
They're not, so the client isn't sending you 50,000 IDs.
Yes.
You've like kind of pre-computed that list and you generate that into a set. But I'm assuming you cache that for some duration, even after you've built the bit set, you cache that for some duration knowing that the user's got a session, right, and that they might be around for a few minutes? Really?
No. Just doing that is pretty quick. I mean, if you go on Etsy and favorite some stuff.
Yeah, see, I would assume you would have to assume, like, okay, if they click once, they're probably going to click again, so let's cache that for 5 minutes or something. But if you can get away without it, even better.
I mean, it's in the filter cache, right, that bit set. So if the same...
Oh, okay, so you are, okay, right. So if the same user comes back, the filter query as a cache key is just their user ID, so you get to reuse it for that duration.
Well, and there was one, we actually implemented it 2 ways. And the first way we did use the user ID, and so we probably had a much higher cache hit ratio.
Right.
But we turned that around and actually had the web servers send us over the IDs. So it's a little bit more painful, but...
You'd still get the cache hit, though.
It would just be
a larger key. Yeah, it's a larger key. Okay, interesting. All right, do your job, guys. You've been slacking off.
Maybe while they're deliberating, you can answer that question. My question is about having a magic box, which will contain Hadoop.
I'm going to give a Grant Ingersoll type answer to this. As we see lots of talks, but can be nice to have a roadmap or more vision on this. Yes, it would be nice to have more vision on this and a roadmap. That is my final answer.
So let's see. Do we have to be present to win, or we're going to get them the prize somehow?
So you got to be present to win.
No, we didn't say that. We said you didn't have to be present. We already said you didn't have to be present.
Who said that?
I said that because you told me that. It's on the blog.
So according to the judges, this is judge ruling. All rulings are final. The third place prize is Balaji Ravi, massacring his name again, rejecting rules. Rejecting documents based on rules, how to post-process them, et cetera, et cetera. So that was number 3,
that's
correct?
Fair. Third place. I forgot the post-filter API.
So that's $25. Do I get 25 euros?
Euros.
Sorry.
Think about the exchange rate.
I forgot to switch my locales. So that's number 3. And I guess we've got to do drum roll. I'm going to just go to number 2 now, and this is, I know this guy is present. Where did it go? Vishal, you've got number 2 with the time-based chronology question.
Wait, what was number 1?
50 euros.
50 euros.
That's number 2. What the hell? Yeah, Jesus.
And I know right now he's saying, damn, why didn't I have him ask the other question first? But I just randomly picked, and I think that was the first one in the order. And number 1, I can't do a drum roll. It is Renee, and he's not here either, is he? He or she? Or he is?
Oh, well, yeah, no, he's here.
All
yeah,
right,
okay.
Right.
That's fair. That's close. I probably would have swapped him.
Money. There you go, sir.
I probably would have swapped him. Yeah. Yeah, no.
And that is it. Next year, if you have better questions to Stump the Chump, the moderator does take bribes, as do the judges.
That's pretty good, because I'm going to be moderator next time, I think.
All right. Thank you.
What do they need to know?
Want a party?
Hold on, wait.
We've got to say thank you to Mr. Hausman, our chump. I did this last year. It sucks being the chump, but it's also great.
Okay.
Also, thank you. Big round of applause to our beautiful judges here.
And our moderator,
Mark Miller,
Grant.
Jan Hoydal, and Yannick Seeley.
And thanks to the moderator, Grant, who had to collect all the questions and type them up and make sense of them.